Assalamualaikum, my name is Nurina Biha binti Muhammad Anwar. My presentation for final year project entitled the Phytoremediation of removing heavy metal in wastewater sludge using Bougainvillea. Wastewater treatment produces massive volumes of sewage sludge due to rising population and rapid urbanization. It greatly strains the environment, causes many types of biological and chemical pollutants. Environmentalists are interested in using sludge to solve environmental issues and costly treatment plant by phytoremediation to remediate heavy metals to improve sludge quality with a more economical and environmental approach. Ornamental plants have found a green remediation approach in sewage sludge in extracting and stabilizing metals. Problem statement: heavy metals in sewage sludge endanger individuals and environment. Chemical precipitation and fluctuation of heavy metal sludge are costly than immobilization. Sludge management costs more than liquid treatment at treatment plants. Using nutrients from sewage sludge, farming can replace synthetic chemical fertilizer. Sludge with high contaminant levels make this disposal approach difficult. Significance of study: phytoremediation is cost-saving strategy, has aesthetic value, and it is environmentally friendly. It is also solar-powered, self-sustaining system, help to preserve natural diversity, and act as alternative to chemical fertilizer in agricultural setting. Objective of this study is to characterize the soil property in texture and pH, sludge pH that influence the plant growth and performance of phytoremediations. Second, to measure the accumulation of heavy metals in plant parts using ICP-OES and to determine the removal efficiency percentage of ornamental plants, namely Bougainvillea, in eliminating heavy metal from wastewater sludge. Literature review. Based on Lead in All 2020 study, sewage sludge contains zinc, copper, lead, and cadmium, and other persistent organic contaminants are found in sewage sludge. According to Taylor's 2020 research, sewage sludge collects heavy metal from effluent wastewater, which may influence the treatment and final product quality. Finally, Abdul Aziz 2020 observed that wastewater has the most cadmium, lead, and copper, which harm the environment and humans. Background and mechanism of phytoremediation. Phytoremediation, or known as botanical bioremediation, uses green plants to eliminate environmental poisons or transform them into harmless molecules. It is green technology. It's recommended for its reduced cost, environmental effect, and public acceptance. Mechanism of phytoremediation. Phytoextraction occurs when toxic metals infiltrate roots, shoots, and metabolically inactive plant tissues. Reservoir precipitation, metal valence reduction, and root tissue absorption stabilize the heavy metals in phytostabilization. Reservoir filtration absorbs wastewater and polluted groundwater toxic and extra nutrient using a dense root network by absorption and absorbing pollutants on the root, and the foliar system transforms pollutants into phytostabilization safe volatiles and release to atmosphere. Ornamental plants in phytoremediation. Research found that Bougainvillea may phytoremediate lead and cadmium polluted urban soils and absorb soil metal without morphological damage. Phytoremediation capacity of ornaments have root, stem, and leaf morphology. Determining the accumulation capabilities of plant organs boosted the efficiency of the remediation process. Methodology 1. 20 Bougainvillea were placed in polybags for 1 month and propagated using stem cuttings, at least 7 nodes, and leaves removed to produce similar to parent plants. After measured, the plant was moved to 5 soil sludge treatment mixtures with 100% salts, 25% sludge, 50% sludge, 75% sludge, and 100% sludge for 1 month. In these periods, the height of plant, soil, and sludge texture and pH were determined by field method, pH meter, and also measuring tape. Methodology 2. Sample preparation of plant parts and mixture soil sludge sample based on wet digestion methods. Samples were dry and grinded by mortar and pestles into powder form, and plant samples were digested with 2 ml nitric acid and 6 ml hydrogen peroxides, while mixture soil sludge sample were digested with 12 ml nitric acid and 4 ml hydrogen peroxides. Plant samples were heated on a hot plate at 120 degrees Celsius, while mixture of soil starch was at 130 degrees Celsius for 2 hours. Filtrate and diluted the sample with deionized water or distilled water until calibration mark. Both samples were put in polypropylene container and chiller before analysis. Cadmium, copper, lead, manganese, and zinc were analyzed with single element standard solutions, 1000 mg per liter, to prepare the standard solution and calibration standards. All elemental calibration curve for plants were 0.5 to 3 ppm, and soil sludge mixtures were 2 to 10 ppm. Result and discussion. The growth of plant increased over time after 1 month of observation. The highest plant height was 40 cm with 100% sludge, and the lowest height plant was 50.30 cm with 25% sludge at 4th week. Loam and slightly acidic soil sludge at pH 5.4 affected the soil quality, nutrient availability, and plant growth. Soil sludge mixtures also alter the heavy metal availability. Concentration heavy metal in Bougainvillea roots. As shown above, zinc accumulates more in roots than other plant tissues. Zinc bioavailability depends on absorption, desorption, and solubility. Variables influence the zinc bioavailability like pH, mineral composition, soil organic matter, root exudates, and rhizophoric bacterial populations. Zinc distribution and speciation depend on soil pH, which affect the zinc solubility and sorption. Time release and soil phytochemical changes boost the zinc availability. This modification helped plant roots absorb zinc. Planting medium soil pH was 5.5, and it shows soil pH considerably affects zinc solubility. Concentration heavy metal in Bougainvillea stem. The highest accumulation of manganese was found in aerial parts of plants like stems and leaf. That shows ornamental plants in phytoextraction has high amount of biomass, which facilitate accumulation heavy metal in their above ground biomass. Plant roots execute protons, carboxylates, and enzymes, affecting soil manganese dynamics. Protons increase rhizosphere manganese availability in 2 ways when it exchanges manganese immobilized by negatively charged organic matter and clay minerals. It also lowers the alkaline soil pH and releasing manganese. Accumulation the least heavy metal in plant parts and leaf. Accumulation of manganese was found the highest in leaf due to phytoextraction, depends largely on above ground biomass. Zinc and manganese accumulate more on plants than cadmium, copper, and lead. Environmental changes affect the plant interiors. Plants' ability to survive environmental conditions depends on their anatomical changes, and metal absorption and transport to above ground plant tissues vary by species. Percentage removal efficiency of ornamental plant. Overall, heavy metal removal was highest for cadmium and manganese in treatment B, lead in treatment C, and zinc and copper in treatment D. The lowest removal efficiency percentage, cadmium followed by lead, zinc, copper, and manganese, was the highest removal within 5 different treatments. Variables influence the phytoremediation efficiency performance, such as pH, temperature, weather patterns, water availability, and biomass of plants. Hydrous oxide and minerals which absorb heavy metal ions dissolve as pH drops. Low pH levels enhance heavy metal ion mobility, and plants that has more biomass absorb more heavy metal from the soil. Variations in external temperature can alter plant transpiration rate throughout the phytoremediation process. Strong winds can have a substantial influence on the rate of evaporation in plants, impacting heavy metal absorption during the phytoremediation process. Conclusion and recommendation. Accumulation of heavy metals in the Bougainvillea plant was highest in roots, followed by leaf and stem. The highest removal efficiency of plant was manganese under treatment B with 70.05%, and it shows that ornamental plants can effectively remove heavy metal from wastewater sludge. The efficiency of phytoremediation can be improved by transitioning from the laboratory to practical large-scale applications. It includes the growth rate of plants and environmentally adaptability when choosing prospective different types of ornamental plants. That's all from me. Thank you.